Now, I think we've done quite a lot of work on decimals now, a lot of recapping work on decimals. So I think we can go back to this grid investigation that we briefly looked at a week or so ago. Now, if you've already done this, then brilliant, you've done today's work. There's always maths frame and other things that you can spend your time on. If not, well, let's have a quick go through this now. So, the first thing is to estimate how many numbers there are in this grid, and then count to check. Estimate really does mean have a sensible guess. Counting, I think even counting in a kind of I recognise an array and I'm quite clever way, probably is cheating. But when you do have to count to check, I don't think you need to count each individual one. I'll leave you to think about that one. It shouldn't be too tricky. When you write down what your number is in your book, could you tell me if there was anything that you thought of while you were doing that? Now, that's number one. Number two, find a number that lies between 8 and 9, or 10 and 11, or etc, etc. Now, these first three, these are whole numbers, these are integers. So, if you're looking for something that lies between a number and the next one's number, it's going to be decimals that you're looking at, whether it's the tenths or the hundredths. Everything between 8 and 9 is going to be 8 something. So if I was looking at numbers between 4 and 5, the moment I get to 5, I'm past this. So it needs to be 4 point something. 4 point, and then pretty much anything in here is bigger than 4, because we've got some tenths and some hundredths on top of the 4, but it's less than 5. When you get to D, and you're looking at the difference between 7.5 and 7.6, well, if we look at decimal numbers, if we've got something like, I don't know, 4.3 and 4.4, 4 point is going to be 4.3 something, because the moment we get to 4.4, we're at the next one, and it can't just be 4.3 or 4.30, because, well, that is this one. We need something that sits in between. So 4.31 or 4.32 or 3 or 4 or 5 or 6 or 7 or 8 or even 9, everything, anything in here would be in between these two numbers. So when you have a look at that one, think about that logic. Right, third one. Write the yellow numbers in order from smallest to the largest. There's 1, 2, 3, 4 yellow numbers. Now, when you're ordering numbers, the further to the left a place is, the more it's worth. So first of all, you look to see, do any of them have any thousands? If they haven't, you move on to your hundreds. If they haven't got any hundreds, you move to your tens. If they haven't got any tens, you move to the ones. You look for the one with the biggest digit. If two of them have got a draw, then you look to the next column. And if that's a draw, finally you look to that column. But the moment you find a difference, you don't need to look to the next column. So if I was ordering, I don't know, 4.7, 4.3, 5.1, and 3.8, I would say, do any of them have any thousands? No. Do any of them have any hundreds? No. Do they have any tens? No. Do they have any ones? Yes. Okay, which is the biggest ones? Well, 5 is the biggest ones, so 5.1 must come first. Okay, what's smaller than 5? Well, it's 4. Oh, well, there's 2 of them that got 4. Now I go and look at the tenths column. 4.7 or 4.3. I'm not even going to look at this one, because 3 is smaller than 4. So 4.7 or 4.3, well, 7's bigger than 3, so 4.7 comes next, then 4.3, and then finally 3.8. Now, what you could do in your head is basically times them all by 10, as in ignore all the decimals, all of them, and put the decimals back in again. But that only works because all of these yellow numbers are one ones, something in the ones and something in the tenths, no tens and no hundredths. The next one's follow a trail, start on 9.7, which is the purple one. Let's get rid of that. So you're going to start here, and then basically you can go in any direction. Can you go diagonal? Not diagonally. So starting from here, you can go that way, or that way. You have to find a number that is bigger. So 9.7 is 9.65 bigger than 9.7. Well, no, because this is 9.7, that's 9.6. The fact that it's 100 doesn't make any difference. That's ignored as the 10th column has got something in it. So you pick your direction, I could jump straight to 30.9 because that is bigger than 9.7, but then I'm going to be stuck because nothing around it's bigger than 30. So I think I would probably go to that one, and then I'll follow that logic all the way through until I get to the point where there are no larger numbers. Next one is choose 3 of these blue numbers. There's 1, 2, 3, 4, 5, 6 of them, and then split them into ones, tenths and hundredths. So let's do something as an example that isn't one of those. If I had 5.27, that's 5.27. Well, that equals 5. And then here we've got a 0.2, so add 0.2, and then this is a 0.07. 0.07. I have to have these placeholders here, because if I just put 7, people would think it was 7 in the ones. They need to know it's in this hundredths column. Write the green numbers in order. That's just like doing the yellow numbers, except they've got tens in them as well. So you'll start by ordering the tens, then you'll order the ones, and then you'll order the tenths. Okay, next page. How many blue numbers have 9 as their 10th digit? Well, you can get something like this, frame thing I've drawn at the top here. You could write each number in it, and how many of them have 9 in their 10th, tenths, not tens, 10th digit. How many of them would end up with a 9 here? So you write the number in, so 3.26, 62, not 26. Does that have 9 in its 10th digit? Well, no, it doesn't. It has 6 in its 10th digit, so it's not that one. And then you just go through all 6 of those blue numbers until you find all the ones that have got a 9 in the 10th digit. How many pink numbers are there? Estimate. Yeah, so about how many? It's about. It doesn't need the exact answer. It's asking for an estimate. About how many pink numbers are there? Well, if you worked out at the beginning how many numbers there are altogether, you can probably have a good guess at how many of them aren't pink and take that away from how many are there altogether, and that will give you an idea of how many are pink. Yeah, I've probably given away too much there, but never mind. Round the nearest yellow number. Round each yellow number to the nearest 10. Well, if you had something like 3 point... What yellow numbers are they? Yeah, they're one-digit numbers. 3.64. 3.64. We're rounding to the nearest 10. That means we're looking at this column. All of this is completely irrelevant. Doesn't matter. Does 3 round up or does 3 round down? Well, 3 rounds down because it's not 5 or more. It's 4 or less. So that whole thing would round down to 0. And then you've got 1, 2, 3, 4 of those to look at. One of those is an odd one out. Can you spot which one it is? So done that one. If I round all the yellow numbers to the nearest whole number, 2 of the numbers have the answer 6. Which numbers are they? Well, let's talk about rounding to the nearest whole number. if instead of rounding to the nearest 10, I was rounding to the nearest whole number, 3.64. This is the whole number. Whole number is 1s and above. This is what we're trying to get rid of. So I look at the next place, this one. This is irrelevant. I just look at this. Is 6 5 or more? Well, yes it is. So it rounds up and we get 4. So rounding out to the nearest whole number gets us 4. Whereas rounding it to the nearest 10 costs us 0. Choose 3 blue numbers and round them to the nearest whole number. It's the same thing again, but I just think the blue numbers have got some hundredths. But if you're rounding to the nearest whole number, the hundredths are irrelevant because you're only ever going to look at the tenths column. And then finally, there's quite a big question at the end. Solve these puzzles. There is a yellow number which when times by 10 you get a pink number. Now, when you times by 10 you move to the left. So if I was to have something like 4.3 and I was to times it by 10, am I allowed to? Oh no. Am I allowed to do this selection tool? Yes, I am. Timesing by 10 means moving them along. So 4.3 becomes 43. 4.3 times 10 becomes 43. Because when you times by 10, all the digits move one place left. So you're looking for a yellow number, which when all the digits are moved one place to the left is the same as one of the pink numbers. And I'm guessing there's probably only one possibility there. Now the next one, a green number, which when divided by 10 is one of the pink numbers. Well, if timesing by 10 goes to the left, dividing by 10 has got to go to the right. So if I had 25.2, so 25.2, and dividing by 10 is going that way, all the digits move right, well then, no, don't stretch the digits, there we go, they'll move to the right, it becomes that. 22.52. 25.2 divided by 10 is 2.52. This is why we don't say timesing by 10 is just putting a 0 on the end, and dividing by 10 is just taking away a 0 from the end, because when you have decimals, that doesn't work anymore. It's about moving left and right. So times by 10, all the digits move left. Divide by 10, all the digits move right. Notice that these two are add, not times, not divide. I know you can add, I know you can take away, you don't need to, but I know you can because you've just done sheets of work on that. So, I don't think these are massively tricky, and you have seen them for quite a while now, so hopefully you've had a chance to have a look at it. Do what you can, do your best. If there's some that you can't do, it's not the end of the world, don't worry about it. Let's just see what we can do. Now obviously tomorrow I'll be doing this, well sorry, by the time you read this it'll be today, so on Monday I'll be around in the morning for helping, but in the afternoon some of us will be at school with our class picnic, so I'll see some of you there. If not, it's not the end of the world. I will see the rest of you. I'll still see you online on Edmodo, and I'll see you when we get back to school in September. Those that I will see tomorrow, well, this afternoon it'll be by the time you see this. I'll see you then. Everybody else, don't forget, I'm not going to be answering Edmodo because I'll be at school. Okay, have fun with this.